Today we're going to talk about what is called binomial probability. Now, if we recall, we learned the binomial theorem yesterday, and for our binomial theorem, we learned that the sum from r equals 0 to n of n choose r times x to the n minus r, y to the r, can be used to expand any binomial raised to any power. And we can use this theorem to help us in cases of binomial probability. So when would we use this? We would use this if there is a fixed number of trials, if you are only considering two outcomes. So it's a yes or no, it's a success or failure. There are only two things that could happen. They're all independent trials, meaning that what happened one time does not affect what happens the next time, and every time it is the same outcome. So good examples of this would be when you flip a coin over and over and over. If you try to take a basket shot over and over and over, your probability of the success is the same each time. The way that we're going to use binomial probability is we are going to let each term represent a probability of a certain number of successes. We will let n equal the number of trials and r equal the number of successes. The formula that we will use here is we will say n choose r times the probability of a success raised to the r power times the probability of a failure raised to the n minus r power. So basically this is saying what is the probability that you would succeed over and over and over times the probability that you would fail the remainder of the number of times. Alright, so let's see how this plays out. In our first example, you are on time to class 40% of school days. In 4 days' time, what is the chance that you are on time exactly once? So in this case, since we are talking about 4 days, we would say that n equals 4. We would say that r equals 1 because that's the number of successes that we want. And the probability of a success is 0.4. Therefore, the probability of a fail, or being late, would be 0.6. So then I would say 4 choose 1, my n choose r, times probability of success, 0.1 to the 1 power, times probability of failure, 0.6 to the 3rd power. Then we would go ahead and multiply this out, and we get 0.346. Now the probability that you are on time all 4 days, well here our n is still equal to 4. The difference is that now r is equal to 4. The probability of a success is still 0.4, and the probability of a failure is still 0.6. So I would say 4 choose 4 times, we're going to have 0.4 to the 4th power, and then 0.6 to the 0th power. And this would give us 0.026. Alright, if we look at our second example, go ahead and read the problem. Problem says that we have a 75% chance of hitting the target. If you take 10 shots, what is the probability that you make 7 of them? Again, we are always looking at what is the probability of success and how many are we trying to make. So in this case, n is going to equal 10. We want to make 7 of the shots, so r will equal 7. I have a 75% chance of making the target, so probability of success is 0.75, therefore probability of fail is 0.25. So now I go ahead and say, alright, out of 10 tries, I want to make 7. The probability of success is 0.75 raised to the 7th power times my fail to the 3rd power. And if we multiply this out, we will get 0.250. Alright, put this on pause and figure out part B. and we should get 0.282. Now the next scenario we're going to look at involves those key words that we've talked about many times, at least. And in all of our previous examples, when we've seen problems that involved words that denote an inequality, at least, at most, no more than, no less than, in all of those cases, we have to figure out all of the possible ways to fulfill this criteria, find their individual probabilities, and then add them up. So if we look at what we have going on here, we have 80% of the students pass the final. If you have 7 friends taking the final, what is the probability that at least 5 will pass? So first, I'm going to figure out the probability of 5 people passing, then probability of 6 people passing, and then lastly, the probability of 7 people passing. Pause the video and try and figure all of these out on your own. For our first one, we would have 7 choose 5, 0.8 to the 5th power, 0.2 to the 2nd power. Here we would have 7 choose 6, 0.8 to the 6th power, 0.2 to the 1st power, and then we would have 7 choose 7, 0.8 to the 7th, and 0.2 to the 0th. If we add all of these individual probabilities up, we will get 0.852. Now you'll notice that in my work here I'm writing down many decimal digits, so that way at the very end, after I add them together, I'm only rounding once. If you round every step of the way, you will keep on compounding your rounding error. Alright, go ahead and set up the last problem on your own. The correct answer is 0.005. If you get it correct, you're good to go. Otherwise, I will explain how to do it now. So if less than 3 pass, then that would be the probability that 0 pass, probability that 1 pass, probability that 2 pass, and then we stop because less than does not include 3 people passing. So we would have 7 choose 0, 0.8 to the 0th, 0.2 to the 7th. We would have 7 choose 1, 0.8 to the 1, 0.2 to the 6th, and then 7 choose 2, 0.8 squared, 0.2 to the 5th. And then for those of you that are using graphing calculators, one thing that you would want to try here, after you get this entered in and hit enter and get your decimal, you can go into second enter, and then it will allow you to see what you just typed in. So you can go in there and you can edit these exponents and this value here, because really that's all that's changing each time. All of these are the same. So you can keep on going back and do second enter, change it, write down your decimal, second enter, change it, write down your decimal, and then that way you don't have to type in all of those over and over. Alright, that's it. We're done. Good luck with your homework.